Okay, let's take a look at this homework assignment. I got a couple questions I want to address. We're going to be comparing cards with a capital C. So that right away should remind you, oh wait, we can't do equal signs, because that checks to see if they're pointing to the same thing, not if the thing in heap memory has the same value as each other. So I don't care if these cards are saved in different spots in memory. Like this might be their memory location. So if I said this card equals this card, it would be false because they're saved in different spots in memory. And equals compares the stack value of these, not the heap value. And so in the heap, their value that I would have to use a dot method to get is much different. So I'll do this one dot equals in parentheses this one, and that way it'll compare their actual values. So don't use double equal signs when you see if the thing is capitalized, you can't use double equal sign. You have to use dot equals. So part A of this problem is asking to see if we can loop through this and check to see that there are only two pairs. So this would be a valid arrangement because each card, that every card has one pair and one pair only. So this would be a valid arrangement because as I scroll through this, I see 1 and 1. There's 2 yellows, 2 grays, and 2 greens. It checks out. If there were 3 or 1 of any of these, it would be no good. It has to be just even pairs. So one of the ways I want to do this is that you can have a nested loop structure. There's more than one solution, but the nested loop structure is sort of what we've been studying. And so what I'll do now is I will have an outer loop that will go through each card, and then an inner loop that also goes through each card. But this outer loop will, let's say this card is being looked over by the outer loop, and the inner loop will then go through and check all of the cards, including the one that the outer loop has. So if this is X going through here, then Y will check the same card as X, and it will count, saying, hey, I found a pair. It's actually the same card as the outer loop, but we'll count it. And then this won't be a pair, but this one, so it'll go up to 2, and then won't count. And then, so when the inner loop ends, I should have found 2 pairs exactly, two counts, and you'll start a counter before the inner loop gets going, and then you'll count how many maxes you've had, and then after the inner loop you'll say, okay, does my count equal 2 and exactly 2? If not, cancel this, return false. This is not a good setup. If it is, then go on to the next one, and I'll check this one in my outer loop. This is now where my X is. And my Y iterator will go through. It'll find one of the same match of wherever X is, and then it'll find another dot equals match, and the count will go up. And then once this concludes, after the inner loop, it'll say, okay, did I find exactly 2? Yes, I did. All right, so that's the way I'll go on to this next one. So that's roughly how this algorithm needs to work. The outer loop goes through everything. The inner loop goes through everything. Before the inner loop starts, you set a counter equal to 0. As the inner loop goes through, every time the inner loop's indicated card matches the outer loop's indicated card, then the count goes up by 1. At the end of the inner loop, you should have a count equal exactly to 2. If that's not the case, then you return false. If not, you go through and keep going. If you make it through the entire thing without ever returning false, at the end of your outer loop, you can finally return true. And that's the algorithm for part A. So for this, for part B, we're just removing a card, and you have a description here. And I usually find the java.com is the most helpful place to start. And all that you're asking here is that if I wanted to remove a card, just shift down all the others instead. and you can leave a blank spot here. Or you don't even have to leave a blank spot, you can just ignore it, is what they're saying. They have a variable called numCards that keeps track. So even though that an array is immutable and you can't change the size of it, we have like a number that keeps track of how many cards, how many spots are legit. And so that if I were to bring this down, I just bring numCards down. So even though that, here, let me walk you through what the answer kind of looks like. And so if I wanted to delete this card, one of the ways to do that is start one spot after that, and then say, hey, the card before this one should be equal to where I'm at right now. So basically, I just make a copy of it and copy it over here. And then the counter goes off to here and says, hey, the card before this, make it a copy of this right here. And then I go to this one and do the same thing. And then what I do is I bring numCards minus minus, and so that just sort of makes the boundary here to divide it. Even though that the original card is actually still there, we won't look at it because numCards, which is our counter, has been reduced. And part C is actually really easy. If the two cards match, and you can check that really quickly, if the two cards match, then you use the remove card function that you made in part B to remove them, the two of them. So that's pretty easy. So if they're equal to each other, then you remove them both. If they're not equal to each other, then you just return false.